If, like me, you're curious about what is a smart building ontology and have experts walk us through how you can work with smart buildings with Azure Digital Twins, Alina and Carl are here today on the IoT Show to tell us everything you need to know about Real Estate Core and Azure Digital Twins put together. This is today on the IoT Show. Hi, everyone. This is the IoT Show. I'm Olivier, your host, and today we have two guests to discuss smart buildings ontologies and something called Real Estate Core that Carl will tell us a lot about. But before we jump into the actual topic, we'd like to know our guest a bit better. So Alina, you go first. Alina, who are you? What are you doing at Microsoft?
Hi, Olivier, and hi, everyone. Thanks for having me. I'm so excited to be here and talk about smart building ontologies and collaboration with Carl and Real Estate Core Consortium. I'm a senior program manager at Microsoft, working on Azure IoT Smart Places and Energy, which drives the emerging smart buildings, smart cities, and smart grid segments. I'm also an Azure Digital Twins pioneer. I work on the platform since early days, and I continue even today to accelerate Azure Digital Twins partners and customers to build their end-to-end solutions on the platform.
Nice. Thanks, Alina. And so if you've actually been interested in digital twins and seen some of our demos, Alina usually is behind these demos. Carl, so how about yourself? So where are you calling us from? What are you doing in life? Who are you?
Yes, hi. I'm calling from Jönköping University, Sweden, where I am an assistant professor working on ontologies and ontology engineering. And that's something I've been doing for 10 years or so, and most recently within the smart buildings segment, and co-founder of the Real Estate Core Consortium that Alina mentioned. And I'm very much looking forward to showing you what we're doing with that.
Nice. So we'll talk definitely about, how Real Estate Core is binding or bridging into digital twin world at Microsoft and how that collaboration is going. But before we do that, we need to understand a bit better, what is Real Estate Core? What is it that you and your team are doing? And also we are telling, people about ontologies. We're using that word. Myself, I need to have some more of a description or definition of what this is. So can you give us a word about Real Estate Core and how they relate to smart building ontologies?
Yeah, so to begin with, an ontology, if we leave aside all the complicated academic jargon, what we're essentially talking about is a shared data model for some domain. So, it could be IoT systems or academic publishing or web content or building structures in this case. And so we use this as a schemas for knowledge graphs typically. And by having these shared ontologies, these shared data models, we can harmonize things like query libraries and software components and documentation and so forth, so that we can reuse that rather than build it anew every time. So there's an advantage in terms of not having to run into the same problems that people have done before, and there's an advantage in terms of being able to reuse existing data and go quicker to market, basically.
Got it. So I'll switch to you, Lena. So we're talking about Real Estate Core and how we are binding or bridging into the Microsoft world, right? And so that connection, that relationship between the ontologies that Real Estate Core is working on and the Microsoft world go through something called DTDL. Can you tell us a bit about what is DTDL? We covered that in various episodes, but I think in the context of today's discussion, it'd be interesting to have your input on what it is and how to understand it today.
Yeah, so first of all, I invite everyone to watch IoT Show. We do have an IoT Show which goes deep in digital twins definition language. This is the abbreviation DTDL. So please make sure you are watching it. But just like to set this our audience today, DTDL, it's an open modeling language which allows users to define custom domain models for any connected environments. DTDL, it's also the modeling language for Azure IoT services, and like IoT Hub with plug-and-play devices, digital twins, IoT Central, just to name a few. And since the DTDL is just a modeling language for Azure digital twins and just a blank canvas, it is very important to accelerate developers' time to results by providing a domain-specific ontology to bootstrap solution building, as well as seamless integration between any vendor, different vendors, and Azure digital twins-based solutions. Microsoft view and approach here is to provide open source ontologies based on industry standards like Real Estate Core that will be refined with our partners and consortiums, and they will be, of course, validated and deployed at customer sites, including Microsoft Campus, because ultimately, an ontology is as successful as the solution in which it is utilized.
Okay, that makes sense. So now back at you, Carl. So we're talking about, putting these things together. And my understanding that real estate core is not something that is like just born out of nowhere. It's something that's been here for some time, or you guys have been working on. And you're working on a different definition language than DTDL. And we're talking about bridging these two worlds. So tell me a bit more about real estate core, what it's made of and what it's built on. And then we'll talk about the integration with DTDL.
Yeah. Sure. Real Estate Core is originally built using something called OWL, which is a W3C spec modeling language for the semantic web. It reuses lessons learned from other ontologies in this space, including modeling of sensor data, building spatial structures, building systems, and so forth. So we've taken the best of what is there and integrated it in a way that makes sense for a real estate owner. And what we're doing is that we're taking this OWL ontology and we're passing it through a translation mechanism that we built, a translator tool that is open sourced and is published alongside our ontology to generate a DTDL definition from it so that it can be run within the Azure ecosystem. And this automation is key because it allows these two versions of the ontology, the source OWL ontology, if you will, and the DTDL version, to stay in sync as they are both developed going forward. So we can do automated translation from one to the other. And I'm going to start to show you a little bit of what is actually inside the real estate core ontology, bringing up a slide here. So here is some of the concepts that I'm showing on the screen now that are in the real estate core ontology that are relevant for building smart building solutions. So we have on the top left a spatial model, the blue things there, where you have subclasses that extend the base space concept, and spaces can be part of other spaces, as you see through the little arrow there. So that's how you nest things like rooms, which are within floors, which are within buildings. On the top right, the green boxes, we have assets. So these are things that are placed inside of the building, but aren't actually part of the building structure itself. And examples here typically include plumbing and HVAC systems and furniture and movable partition walls, etc., IT equipment. And again, these can be nested within one another, and they are located in these spaces. And then the orange bit at the bottom there are capabilities, and these are alike to points in building management systems, or perhaps affordances in the Web of Things specification. And these basically describe a capability or functionality on some space or asset or logical device, which we'll get to shortly. So these are things like sensors. A room can have a sensor, or an HVAC system can have a temperature sensor built into it. The gray box there, logical device, represents the software that executes and somehow shuttles this data into a digital twin environment, such as Azure Digital Twins. And then in addition to these things, we of course also have building components. So the structures that make up the building itself, the physical floors and so forth, and balconies, etc. And agents representing persons or companies or departments within companies that play some role within the building. So this is the overall structure. And this is all described in great detail on in the GitHub README and documentation.
Yeah, that we're actually going to have links for in a blog post that we will mention at the end over here. So if I sum it up at a high level, these ontologies defines the various entities and describes their relationships, right? And here we're talking about your building. Well, now I guess what I would like to see is you mentioned a open source translator to go into the DTDL world that allows to get into the Azure services as a platform to implement, analytics and other things on top of that data coming from these things, these entities, and interact with them. So let's get into that demo thing and see how we go about coming from that OWL environment of Real Estate Core into Azure Digital Twins through the DTDL translator.
And now we are going to show you how to use Real Estate Core ontology in 2 Azure Digital Twins instances, one for our building 121, and another one for Karls University, John Copping in Sweden, which are both using the same ontology, but they don't have necessarily the same graph of twin instances. So now my demo will run over a few steps to show you how you can upload all of these models. We have around 400 plus models, how to visualize them in a model visualizer, how to build the graph with a sample app, which is open also in Azure Digital Twin samples, and how we also visualize the graph instances by running some queries in both of these environments. So now I'm going to load the models. After you clone your repository from GitHub, you will see multiple tooling, like one of them, it's Model Uploader. And of course, you also have a folder called Ontology. And all you have to do is to call the model uploader with a parameter, the folder, which is the ontology. And you will see what I'm going to show here. I just preloaded this. You will see all of the models being loaded in your digital twins. Next, you might use this tool that we are offering. It's in the same repository. It's a model visualizer. And here, this is just the models that I've loaded. And you can see, for example, the asset interface, how asset interface is connected with the space interface. And it has a relationship, which is called located in. It's just another way to view your model, how they are related to each other on a higher level. After you visualize this, then you are going to create, I'm going to create a graph of building 121 with the example that we just showed in the GitHub repo. And I'm going to start populating this graph.
So while this is running, Alina, so here you're in Visual Studio, you're working with Azure Digital Twins. So you have an instance of Digital Twins that's been deployed, right? You've been loading the ontology from GitHub, and you're actually pushing it, or actually the various entities, you're actually creating digital twins for them. And then you are creating that graph on top that will allow applications to interact with the twins, right?
Exactly, yeah. Okay. So here I'm just showing, this is a sample app. This sample app, it's available. I just changed it to create this graph. Essentially, I'm loading, yes, all of the instances here in the graph, building 21, all of this. And then here, now let's visualize this in Azure Digital Twins Explorer. This is another tool that we are offering on Azure Digital Twins. So now this is exactly the graph that we have loaded. For example, you can see here, I have interface called temperature, which has a value of 70. And I'm just going in my GitHub. You have here the sample query, and I'm going to run this query, which shows you all the rooms which temperature are, I think they are, yes, lower than 73.
Nice. And what's interesting here is that you're using a tool which is very visual, allows people to see what they're working with, and also test queries. I would assume that at some point you're not using this tool. You create an application that will interact with digital twins, send the queries, extract the data very rapidly. That's one of the benefits of Azure Digital Twins, and allow you to now visualize only the things that you need to based on the query, right?
That's absolutely correct.
Okay.
So now that we have seen and we have loaded all of the entities for building 121, now I'm going to pass it to Carl so he can show you his graph with his Azure Digital Twin instance, where he already uploaded the same ontology and the same set of models.
Right. So what we are looking at here now is the Azure Digital Twins Explorer view of the Jönköping University School of Engineering graph. And we are using the exact same models and the exact same ontology, but obviously the building and the floors and so forth are different because they no longer represent the Microsoft Building 121, they represent a building in Sweden. And so what we have here is we have the orange box, which is the building. The green boxes there represent floors. The other slightly nuance of green there represent individual rooms. And then on those, we have sensors. And what I'd like to show you now is that I've set up the same query that Alina showed you before, which ran perfectly on Building 121, will execute just as well in this context. The only changes that I have made here is that I've obviously changed the identifier of the building from Building 121 to JTH, the School of Engineering. And I've changed the temperature from 75 degrees Fahrenheit to 22 degrees Celsius because 75 degrees Celsius doesn't quite make sense, and I am in Europe. And navigating the graph here...
I was about to make the joke, Carl, about this one.
Yeah. So navigating the graph here, you'll be able to see that, for instance, on the JTH first floor, there's this one office, which happens to be, I believe, my office. And here's a temperature sensor, and we can see that it has a value right now, 21 degrees. And we can see that this was last updated 1700 hours, 37 minutes Zulu time. So that would have been just now, actually. And the value of this is that we can use the same query, but not only can we use the same query, but we can actually use the same potentially software components for populating the graph and for propagating changes through the graph. So as long as you are using the same set of input devices, you could use potentially the exact, I'm using Home Assistant here to ingest data, but I mean, I could be using any IoT system that works with IoT Edge and IoT Hub. And as long as you're using those same systems, you don't need to customize your software components for your building. You write your software components against the real estate core ontology, and you can then immediately populate your graph from your building sensors. So that saves you a lot of development effort, obviously.
Yeah, I appreciate that a lot. So, and you summarized it pretty well. You know, working against one ontology, which actually happens to be open source, right? That's what you described as well earlier on. You make your application kind of like future proof, right? Because then you can ingest more devices, you can add more devices to your infrastructure, and the application doesn't have to know specifics because it knows the ontology and how to work against it. And that translator, and an interesting thing as well is for you, Carl, as a question is, out there are certainly different ways of describing or building these ontologies, right? You were talking about OWL as a language for building ontologies. I guess there are other ones, right? So hence the interest of having these open source translators that allow to have one system, like in our case, Azure Digital Twins, to work with these different ontologies in a common way. So you can actually extend your twins or have one application managing several buildings where different, languages or description languages have been used to describe these buildings, right?
Oh, absolutely. This is very helpful. If we reach an agreement on the conceptual model level, then, it's simple, a relatively simple matter of translating syntaxes. So from these same models, you could, for instance, and we do actually within Real Estate Core, we do generate REST API specifications following the Swagger spec from these same models. So basically any type of data exchange format can be generated with a bit of effort from these shared models. So the importance is that we standardized the world in a sense, or our domain, part of the world that's relevant to us. And then translating that into some syntactical level that works for different systems and different purposes.
Appreciate that. And so, Alina, eventually, I'm going to actually display down there's this blog post that you put together that go through all of that. Carl mentioned the notion of standardizing how smart buildings are defined. I also said that there are different ways of describing a building, but we as Microsoft really want to push these open source ontologies out there, right?
That's absolutely correct. Absolutely correct.
Cool. And we're working with several partners as well, right? It's a notion of also, working with teams like Carl's, in universities, working on the standards that are useful for the industry, but also working with some players of the industry because they have an input, they have a say in there. They're already, working with existing, tools and description language and standards. So we have some partners we're working with on that.
Yeah, I'm so excited to mention today and to talk about our community who adopted this ontology. And I'm just mentioning a few here. IDON Real Estate Core, it's the Sweden software company, right? We work with for so many years now. They have this platform called PropTech OS, which is currently migrating to Azure Digital Twins. And they are deploying it to their biggest customer, Vasakronan, which is the Sweden's largest property company with 25 million square feet of real estate. And we also have Willow with Willow Twin deploying to their iconic high-rise building, One Manhattan West in New York. And for this, we have another IoT show. So yeah, please follow us on December 9 to watch all the details behind the making of the solution.
Nice. So that's going to be a deep dive where we can actually work with Willow on looking what's under the hoods and how they are doing this building management. Awesome, Carl. Alina, it was a great episode. So we have these open source repository, the blog post coming up. I'm going to actually add it back again down here for you to read. Carl, last word on these collaboration?
Yeah, I've really enjoyed this collaboration with you guys at Microsoft, and what we are looking to enable here is a flourishing ecosystem of people and companies using and interacting with smart buildings through these technologies. So we think we're sort of on the cusp of something quite new here and quite novel and very. We think we can have very substantial effects, both in terms of convenience for the people who live in these buildings and work in these buildings, but also in terms of environmental effects and efficiency and so forth. So really, this is an exciting time to be doing this, and we would love to welcome you guys to visit the Git repository, submit issues, submit pull requests if there's things you want to have covered or you want to contribute. We're very open to that. And also, looking forward, we have ontologies in the smart cities and energy grid space coming also in DTDL.
Okay, looking forward to that and maybe another IoT show episode. We'll see. So I brought that link back here, aka.ms/IoT show/Real Estate Core to learn more about Real Estate Core itself, the open source translator into DTDL, and how you can integrate these ontologies into your Azure Digital Twins. Alina, Carl, thanks a lot for coming up today. And everyone, thanks for watching. Do not forget to subscribe for the show, and see you soon. Bye.
Bye.